Okay, we stopped here, so we'll continue from here in this case. So this is a greenhouse effect. It's showing different sources at the sink, sources and the sink. It's not clear, but if you take a look at this one, probably you'll be able to understand some of it in there. So I think a book has it, or my other the notes, lecture notes has it. So if it's not clear, you can take a look in there. So this then the Lake Erie water pollution due to algae bloom. So in 2014-15 time frame, this is the link. So you guys can go and read a little bit. So the Lake Erie had a algae growth due to the nutrient nitrogen phosphorus disposal over there. So one of the algae was a green, the blue green algae that had a dioxin in there. Dioxin is very carcinogenic and health concern on that. So the city of Toledo experienced that. Then they had to stop the water supply from the Lake Erie and do some activities to remove those the blue green algae from there, and they resume those processes. So if you read it a little bit from the website, then this could be a part of the exam in different exam and other things, so you can explain a little bit. These are used as a contemporary issues in there. So then the Flint, Michigan drinking water pollution due to the lead. The most of the older the water supply system was kind of lead piping, the pipe with the lead. So in this case, due to the pH changes of the water supply, due to less sulfur content and other things, some of the lead were leaked to the water, and people are having kind of like symptoms, different symptoms. Then litigation happened, and the federal government jumped in, and they had to do a lot of alternative water supply system. So the link is there. If you can click on the link and study a little bit, then you should be able to answer simple question as a like the effect of Flint, Michigan drinking air pollution due to lead in there. So as a contemporary issues. Okay, the impacts of engineering solutions in global, economic, and environmental and social context. So couple of contemporary issues we learned in this topic, such as ozone depletion, greenhouse effect, are responsible for environmental pollution that has global implication, as this can affect other territories or countries. So if it is not confined to a part of the area, whoever is making the pollution, then it could be national, it could be international, it could be global effect. So several anthropogenic activities can generate greenhouse gases that can affect the global warming. As we have learned, water and wastewater treatment plant generate sludge from several process streams, and the sludge are digested aerobically and anaerobically, depending on the process used in treatment and the management of sludge. So depending on the type of sludge digestion, methane and carbon dioxide gases are generated that are considered as air pollutant and as a greenhouse gases. Methane gas is highly flammable, and its LEL is 5% and UAL is 15% by volume in the air. Lower explosive limit and upper explosive explosion limit. An engineering solution that can reduce the greenhouse gases generation and emission will reduce the global warming. So the methane gas can be captured and burned to heat houses or offices, or just burned with the flare to reduce the concentration in the air, and or can be refined and used to generate electricity. Those engineering solutions of air pollution by methane has a global effect, as it cannot pass to another territory or country to increase the greenhouse gases. This is also an environmental impact, as this engineering solution keeps the air clean. The capturing and using the methane gas as to generate electricity create employment, which seems to be a greater social and economic impact. So the broad education for civil engineering students is necessary to understand the impact of engineering solutions in a global, economic, environmental, and social context. So this seems to be very important to understand this. This is part of the EBIT learning outcome to some extent. So there could be some questions based on that important topic. The next topic is the air pollution meteorology. Air pollution meteorology, basically the atmospheric condition which affect the air pollution, wind direction and speed, cloud cover, radiation reaching the earth, temperature profile, turbulence depends on the temperature profile, precipitation means rainfall, atmospheric engine, we'll see a little bit of atmospheric engine, how it works, turbulence, stability, and terrain effects, the hilly area and the valleys area. Atmospheric engine. Atmosphere is somewhat like an engine. It is commonly expanding and compressing gases, exchanging heat, and generally raising chaos. So the driving energy for this engine comes from the sun, meaning temperature, right? The difference in heat input between the equator and the poles provide the initial overall circulation of the Earth's atmosphere. The radiation of the Earth coupled with the different heat conductivities of the ocean and land produce weather. You know, the weather and the climate, right? So weather is every day, climate is per year, average like say temperature and other things per year. Then high and lows basically it becomes the pressure, right? The high and lows depicted on weather maps are simply areas of greater and lesser pressure. So the elliptical lines showed in the weather maps represent the lines of constant pressure or isobar. This is very similar to the contour map, right? So elevation contour map. So you guys have seen that in surveying. I think you have taken surveying, so you know what it is, right? So in this case, this is called highs, and high pressure is inside, and this is low temperature inside, and high is outside. So if I compare with the contour, this will resemble as a hill, this will resemble as a pond, right? So, and these are the wind direction particular to isobar, perpendicular to the isobar, then isobar becomes like that. If I take a section, cut it here, then you see this one going a little bit, so going a little bit this way, right? So if I take a B, section BB and section AA, like that. Now, high and lows. In these cases, if I'm in the low pressure, so explain a little bit. High pressure looks like I have a small area here, high pressure, right? So it is expanding, going outside. So that means I have a lot of area to dissipate the energy. So this would be like, say, anticyclone, right? This would be part of the anticyclone, and this would be cyclone. Small area, a lot of pressure coming in the short time to that area, it would be a turbulence, right? So this would be a cyclone. So the wind flows from the higher areas to the lower pressure areas, always to be things like that. On the non-rotating planing, the wind direction would be perpendicular to the isobar. But since there is a rotating, then the angular thrust called the Coriolis effect is added to the motion that I show you the other one. The technical names given to these systems are anticyclone for the highs and cyclones for the lows. So that means highs would be like, say, inside high, it can dissipate energy around, okay? And the lows means, cyclone means lows has a small area, so a high wind pressure wind is coming to cover in a small area, so this would be cyclone. And these cyclones are associated with good weather and cyclones are associated with bad weather. Tornadoes, hurricanes are the foulest in the cyclone, right? So here are hurricane. The definition of hurricane is the type of tropical cyclone with the sustained. I understand the hurricane is basically on the top of the water and tornado is in the land area, right? But some cases definition might change. So I have seen different definition and other things. So in this case, the hurricane looks like exceeds 74 miles per hour, kind of accompanied by rain, thunder, and lightning. Tornado in the rotating column of air ranging in the width of a few years to more than a mile. So that's what it is. So the wind speed of tornadoes looks like from 40 to 110 and span about 75 meters across and can travel a few miles. Here are some of the pictures showing, looks like these are hurricane and tornado versus like, say, this is definitely tornado, this is tornado, this is tornado, these are hurricane, right? These are hurricane. So there are some of the descriptive term over here, cyclone and tornado, hurricane and tornado. So you guys can read those. These are kind of comparative study, comparison. So better to study those a little bit. Okay. So I think I have those in my lecture notes, so you should be able to take a look on that. So high and lows, again the same concept, the high and lows. So in this would be anticyclone. This would be yeah, I think these are all anticyclone. So this is kind of without coriolysis, and this is with Coriolis effect. That means the wind effect, right? That we mentioned before. Turbulence. There are two types of turbulence, mechanical and thermal. Mechanical turbulence, it happens due to random fluctuations of wind velocity to the overall average velocity. The fluctuations are caused by the fact that the atmosphere is being sheared, and the shearing results from the fact that the wind speed is zero at the ground surface and rises at elevation. So the shearing results is a tumbling, tearing motion as mass just above the surface fall over the slower moving air at the surface. The swirls thus form is called the eddies. So, and the small eddies feed larger ones. The greater the mean wind speed, the greater the mechanical turbulence. The more mechanical turbulence, the easier it is to disperse and spread the atmospheric pollutants. So, and the thermal pollutants, thermal turbulence, basically heating due to the sunlight and other things. Heating of the ground surface causes turbulence in the same fashion that the heating of the bottom of a beaker full of water causes turbulence. If the Earth's surface is heated strongly and it turns heated in the air, thermal turbulence will be generated. Then it's measured by kind of stability. The tendency of the atmosphere to resist or enhance vertical motion is termed as stability. So there are three types of stability. In this case, neutral, unstable, and stable. It is relative to both wind speed and the changes in the air temperature with height. This is called the lapse rate. Neutral means the temperature structure neither enhances nor resists mechanical turbulence. When the mechanical turbulence is enhanced by the thermal structure, cyclones are associated with the unstable air. So there's the unstable. Stable is thermal structure inhibits mechanical turbulence. The anticyclone are associated with the stable air. So this is the neutral, looks like neutral. In this case, delta T over delta Z is equal to negative 1.0 degrees Celsius per 100 meter of the elevation. So that means the range of the elevation, this is the height, this is the temperature. Temperature versus this thing, the whatever the slope comes. If it is -1, it becomes the stable. So here is the stability shows, and if it is less than -1, then it is kind of stable. Looks like it looks like unstable. Sorry, it is unstable. So if it is less than that, if it is greater than, then it is stable. The neutral is equal to -1.0. The -1.0 is called the lapse rate. Okay, it's called the standard lapse rate or adiabatic lapse rate. So adiabatic process, a process without addition or loss of heat. So dry adiabatic lapse rate, the rate at which temperature decrease with the things like that, delta T over delta Z is -1 degree Celsius per 100 meter, is denoted by Greek letter gamma. So superadiabatic, so if the temperature of atmosphere falls at a rate of greater than gamma, the rate is said to be superadiabatic. So if it is greater, that means it's stable, right? So if it is greater than this, is stable. If it is less than this is unstable. So subadiabatic lapse rate. So isothermal is there is no temperature change. Inversion means when the temperature increases with the elevation, the lapse rate is called the inversion. Inversion is bad for us because during the inversion, most of the atmospheric pollution come to the Earth's surface that can reach to the people around. So I'm going to stop here, then we'll all discuss more on the stability classes more over there. So this is 121. We are stopping here as a